quiz 7 started with a question about what's a simple random sample. A random sample is a sample in which each member of the target population has got an equal chance of being selected, regardless of their characteristics, regardless of anything about the individual respondents. All they have to be is a member of the population and have as much a chance as any other member of that population of being selected for the sample. When I say population, that can be a population of objects or things or institutions as well as people. A sample that's matched to a target population on its known characteristics is known as a quota sample. We only repeat samples to get a sampling distribution in our imagination, in theory. We don't actually do it in practice. You'd never want to draw more than one sample from the same population in order to measure it. A sample that's cheapest and most convenient to collect is known, funnily enough, as a convenience sample, and they're rarely of any use whatsoever because they're subject to all kinds of selection biases that give different kinds of people or different kinds of objects a higher or lower probability of selection into the sample. There's only one kind of sample from which we can generalize to the population from which it's been drawn, and that's a random sample. What's the standard error of a sample statistic? It's the standard deviation of the sampling distribution. It's just another name for standard deviation of that particular distribution, a sampling distribution of the sample estimate. The amount of variation in the population parameter and the square root of the sample size go into the formula for calculating the standard error, but they're not themselves the same as the value of the standard error. A 95% confidence interval is all of the things described in A, B, and C. The statement in question 4 is true because it's simply a definition of the sampling distribution of a sample statistic. Similarly, question 5, it's true 95% of repeated random samples of the same size will produce a sample statistic that's about 2 standard errors above and below the mean. The real number is 1.96, but 2 is very close. The next set of questions were all about a data set in Excel. We'll just bring that over if I can. Here we go. Question 6 asks you, what's the square root of the sample size for the data set? Well, if you look down the rows of the data set, you'll find that the last entry is in row 1601 and it starts at row 2. So there's obviously 1,600 cases in the data set. The square root of 1,600 is 40. If you want Excel to work that out, just type equals SQRT for square root, brackets, and the number you want the square root of. Press return, and there's your answer. Next you're asked for the mean age of the sample. The age is given by the variable AJ there, and it's again in rows 2 to 1601. So if we put equals average, it's in column H, starts at row 2, colon H1601, hit return, and we get the answer 50.06 or 50.1, and I gave you a leeway of 0.1 either way in your estimate. The next question asks you to calculate the standard deviation of age in the sample. So we go equals STD standard deviation, and we're interested in the same value range again, so it's H2 colon H1601. Hit return, 18.985, which is 18.99, or 19 to no decimal place. Sorry, 19.0 to 1 decimal place, rounding up the nines. The next question was, using the formula for the standard error, calculate the standard error for the mean age of the sample, right? Well, if you remember that the standard error of the mean is the standard deviation divided by the square root of the sample size. There's our standard deviation. There's a square root of our sample size. So let's just do equals standard deviation divided by 40. Press return, and you get 0.475, or 0.47 to 2 decimal places. Calculate the upper bound of the 95% confidence interval. Well, that will be the mean there plus 2 standard errors there. So that will equal mean plus, let's just do it the right way using 1.96 rather than 2, although it'll make very little difference. There's the standard error, close brackets, and we get an upper bound of 50.99, or 51.0 to 1 decimal place. Calculating the lower bound, you just do the same thing, but you're subtracting the 0.477s, and you'll find that that comes out at 49.1. 12 asks you to calculate the proportion of the sample who agreed that all laws should be strictly obeyed, giving your answer to 3 decimal places. The variable for all laws should be strictly obeyed is LWSTROB. That's in column E. Let's just select that column, go to data, go to pivot table, and then in the pivot table builder, drag the variable name to values, and you get a nice little frequency table. You'll see that 1,225 people agree that all laws should be strictly obeyed, and that's out of a total of 1,600. So as a proportion, it's just that divided by, daisy, that, and you get a point. Let's just drag that column so we can see more of the numbers. 0.7656, which will round up to 0.770. Sorry, what am I going on about? 0.766. Can't do arithmetic. The next question, 13, was calculate the standard error of the proportion of the sample who agreed that all laws should be strictly obeyed. So we want the standard error of this proportion, and that's given by the formula square root. So let's just do equals square root, open brackets, and it's the proportion, which is that, times, open brackets, 1 minus the proportion, and then the tricky thing here is to get the right number of brackets. I think that's it. Then we want all that divided by n. which is 1600. Let's see what we get. 0.0105, which will round up to 0.011. Calculate the lower bound of the 95% confidence interval for this proportion. Well, our standard error is 0.0105 or 0.011. We just need 1.96 of them below and above our overall proportion. So our standard error will equal 1.96 times that. Let's just put brackets around it to keep things clear. And we want to take that away from our proportion, so it will be that minus our two standard errors, which gives us 0.7448, which to three figures would be 0.745. The upper bound, again, it's just adding two standard errors, so it would be equal that plus brackets 1.96 times that, and we get 0.786. The 99% confidence interval, we just do the same thing, but we substitute 2.58 for 1.96. 2.58 2.58, and your bounds are now from 0.738 to 0.793, rounding up that 9 after the 2. Then you're asked to produce the 95% confidence interval for the proportion of the population from which the sample, the lower bound of the 95% confidence interval for the proportion of the sample who said doing the right thing sometimes means breaking the law. Let's go back to our original data. That's the relevant variable this time. Let's just do a pivot table as before. So data, pivot, drag that to the values area. So our proportion who agree this time is 871 out of 1600. You'll notice there that there are 41 people who said they don't know. If we treat that as a valid response, we don't have to exclude them before we start calculating the proportion. So we're really getting the proportion of the people who actively agree, and we're treating those who don't know as people who don't know that they agree, as it were. Okay, so we want the proportion 871 out of 1600. And to three figures, that's 0.544. We can then calculate the upper and lower bounds to the confidence interval as we did before. And you should find that the lower bound is 0.520 and the upper bound is 0.568. Then I asked you to review these two answers. In other words, the proportion of people who said that all laws must be strictly obeyed and the proportion of people who said doing the right thing sometimes means breaking the law. And you'll see that there's some kind of paradox there, in that there must be at least some people who agreed with both these statements, even though the statements seem to contradict each other. If you think that doing the right thing sometimes means breaking the law, you presumably don't mean that all laws should be strictly obeyed. The only way around this paradox is not to conclude that there's anything wrong with the data or that the sample's distorted. The only interpretation we can put it is that respondents can interpret questions in a variety of different ways. And I would think it's not unusual, were I to ask you these two questions with some separation of time between them, you might well agree with both of them. And only if that contradiction was brought to light might you qualify your answer to one or other statement to reveal what you really thought about the law. It's just a lesson in the way in which it's necessary to frame questions carefully, but also to interpret people's answers to them carefully. And that was it for quiz 7.